Hello, 7th graders. This is Miss White, and today we're doing this in Module 3 review. Number 1, Gloria says the two expressions 1/3 times 12x plus 15 and negative 4x plus 2 are equivalent. Is she correct? We need to look at these two equations here and turn them from factored form to standard form. So right now they're in factor form, and we're going to go ahead and get started with our first equation here. So I have 1/3 times 12x plus 15. Now, to turn it into standard form, I need to use the distributive property. The distributive property is when I'm going to take 1/3 and multiply it by 12x and take 1/3 and multiply it by positive 15. So when I write this out as a addition problem, I'm going to have 1/3 times 12x plus 1/3 times 15. Now here we realize that we are multiplying with fractions, and when we multiply whole numbers and fractions, what can we do to our whole number to make it a fraction? Well, we can always put a 1 underneath of it. So now I know that I need to multiply my numerators together and then my denominators together. So here I have my numerators. I have 1 times 12x. What is 1 times 12x? Well, that is going to give us 12x. Then here I have 3 times 1, and that is going to give me 3. Now, I have 12x over 3 plus, let's multiply 1/3 and 15 over 1. So looking at my numerators, I have 1 times 15, which is going to give me 15, over 3 times 1, which is going to give me 3. Now I have this equation set up. Now let's simplify our equation. Here I have 12x divided by 3. I need to divide 12 by 3. 12 divided by 3 is going to give me 4, so now I have 4x. Now I have 4x plus 15 divided by 3, and 15 divided by 3 is going to give us 5. Now our first equation in standard form is 4x plus 5. Now let's look at our second equation. It is negative 4 times x plus 2. Again, to get this from factored form to standard form, I am going to use the distributive property, which means I'm going to multiply negative 4 times x and negative 4 times positive 2. When I set this up as an addition problem, I'm going to have negative 4 times x plus negative 4 times positive 2. Now let's go ahead and multiply these values together. I know that negative 4 times x is going to give me negative 4x plus negative 4 times positive 2. Well, I know that a negative times a positive is going to give me a negative, so we're going to be adding negative 8. Another way to rewrite this is when we add a negative, it is the same as subtracting. So we can do negative 4x minus 8. Now our standard form for our second equation is negative 4x minus 8. Now our question is asking us, are these two expressions in standard form equivalent? And is Gloria correct? So are they equivalent? Does 4x plus 5 equal negative 4x minus 8? Well, no, they don't. So they're not equivalent. So is Gloria correct? No, Gloria is not correct. And she's not correct because they're not equivalent. All right, let's go to number 2. Number 2, a new park was designed to contain 2 circular gardens. Garden A has a diameter of 30 meters and Garden B has a diameter of 60 meters. Now that we know that they're circles and that we have the diameters for them, let's go ahead and visually draw that out for us. So here is our circle and we're going to call this A. And then here is our other circle and we are going to call this B. Okay, Garden A, we have a diameter of 30 meters, so we're going to draw the line through it and write 30 meters. And then for Garden B, that is actually bigger. It is going to have a diameter of 60 meters. Let's start with A. If the gardener wants to outline the gardens and edging, how many meters will be needed to outline the smaller garden? So here we know that Garden A is the smaller garden because its diameter is 30 meters. And so we are going to want to find how many meters he will need to outline in this garden. Well, that means that he wants the distance around the circle. So what is the distance around a circle called? Well, that is called a circumference. So we're going to use the circumference formula to solve this problem. You will need to memorize this formula in order to go about doing this problem on your test. The formula for circumference is C equals 2 pi r. So now that we know C equals 2 pi r, we can go ahead and start solving for Garden A that has a diameter of 30 meters. If we know that our diameter is equal to 30 meters, but for a formula we need to know the radius. What is the radius going to equal? Well, radius is half a diameter. So here I'm going to draw the radius of this circle. And so what is the length from the middle of the circle to the outside of the circle going to be? Well, it is going to be 15 meters because radius is half of the diameter. So now that I have 15 meters, I can go ahead and substitute my 15 meters in for r. So now I have 2 times pi times our radius, which is 15. Now, a lot of the time, we have substituted 3.14 in for pi. But our question is wanting us to write this in terms of pi, which means it wants us to keep our pi symbol there for our answer. Now, when we go about multiplying our equation here, we want to combine like terms, or we can use circles and boxes. So here I know that 2 and 15 are the same term, so I'm going to combine them. And because this is a multiplication problem, we are going to multiply them together. So 2 times 15 is going to give us 30, and so we're left with 30 pi. Now, what is the unit measurement we are using? Well, that is meters. So we have 30 pi meters. So now we know that the smaller garden, which is Garden A, will need 30 pi meters of edging. B. How much more edging will be needed for the larger garden than the smaller one? And again, we're going to write it in terms of pi. So we need to figure out now what is the circumference of Garden B, our larger garden. So again, we're going to use the same formula. Circumference equals 2 pi r. And we know that for Garden B, our diameter is equal to 60 meters. And now we need to find our radius for our formula. what is our radius of this circle if our diameter is 60? Well, our radius is going to be 30 meters because radius is always half of our diameter. So now we are going to substitute 30 in for r. So now I have 2 times pi times 30. Now, again, we are going to be combining like terms since we want to keep in terms of pi. So I'm going to have 2 times 30, and 2 times 30 is going to give us 60, and so we're left with 60 pi. And again, what unit of measurement are we using? Well, we're using meters. So now we know that the larger garden will need 60 pi meters of edging. Now we are going to take both of our answers from garden A and garden B and use them to find how much more edging will be needed for the larger garden than the smaller one. So here we're going to have our larger garden minus our smaller garden. So for our larger garden, it was 60 pi meters minus our smaller garden, which is 30 pi meters. So now when we subtract 60 from 30, we're going to get 30. So now our answer is 30 pi meters. So now we know that the larger garden, which is garden B, needs 30 pi meters more fencing. All right, C. The gardener wishes to put down weed block fabric on the 2 gardens before the plants are planted in the ground. How much fabric will he need to cover the area of both gardens? Write in terms of pi. So now instead of using circumference, we're going to find the area. So that is the whole space that is inside of these gardens. We're going to take our larger area plus our smaller area to find the total area that he needs. Now, when we're trying to find area, we need a formula. And because our gardens are circular, we are going to use the formula of a circle. Again, this is another formula that you are going to need to memorize. So the area of a circle is going to be pi r squared. So now when we write out our formula, we're going to have the pi r squared for our large circle plus pi r squared for our small circle. When we write our equation, the difference is that we're going to be using the radius here for our large garden and the radius here for our smaller garden. So let's go ahead and start to write these out. So now I have pi times our radius, which is 30 for our larger garden. So I have 30 squared plus pi times our radius of our smaller garden, which is 15. So I have 15 squared. Now with your calculator, because our problem is wanting to leave this in terms of pi, we are not substituting anything in for pi, but we are going to take 30 squared or 30 times 30. Then you will do the same thing to 15. You can take 15 squared or 15 times 15. Now, 30 squared is going to give us 900. So now we have 900 pi plus 15 squared, which is going to give us 225. So now we have 225 pi. When we add both of these values together, 900 plus 225, it is going to give us 1,125 pi. Now, we are still missing one thing, and that is our unit of measurement. Our unit of measurement here is going to be meters. And because we're talking about area, it is always squared. So we will need 1,125 pi meters squared of fabric to cover both area of the gardens. All right, let's move on to number 3. Number 3, a play court on the school playground is shaped like a square joined by a semicircle. The school wants to cover the play court with sport court flooring. Using 3.14 for pi, how many square feet of flooring does the school need to purchase to cover the play court? The first information that this problem tells us is that we have a square joined by a semicircle. So to find the area of both of those, we are going to add them together. So we have the area of our square plus the area of our semicircle. Now, in order to get this area, we need to know the formulas for that. Again, this is something that you are going to need to memorize. So the area of a square is length times width. So we're going to have length times width plus the area of a semicircle. And when we think about a semicircle, we know that that is half a circle. So we are going to multiply 1/2 by the area of a circle. So now we have 1/2 pi r squared. The values that we need to figure out for a formula is going to be our length, our width, and then our radius of the semicircle. So here, given to me in the square, it gives us our length. And since it's a square, that means all sides are going to be equal. So our width is also going to be 30 feet as well. Because I know that my width is 30 feet, that means that the diameter of this semicircle right here is going to equal to 30 feet. So now I know that my diameter equals 30 feet. And if my diameter equals 30 feet, then what is my radius going to be? And I'm going to make our radius stand out a little bit. Well, radius is half of a diameter, so our radius is going to be 15 feet. Now let's go ahead and substitute these values in. I know that my length is 30. I know that the width is 30 plus 1/2 times pi. Well, this time we're not using in terms of pi. We are using 3.14 for pi. So let's substitute 3.14 in for pi. Times our radius of our semicircle, which we know is 15. And so now we have 15 squared. So in your calculator, we are going to calculate the area for both of these shapes. Here we have 30 times 30, and that is going to give us 900 plus 1/2 times 3.14 times 15 squared. You can calculate this in your calculator, and remember, an easier way to go about multiplying 1/2 into your calculator is putting it in decimal form, which is 0.5. So once you've calculated that in your calculator, you would get 353.25. Now, go ahead and add both of these values together, 900 plus 353.25, and we are going to get 1,253.25, and we still need our unit of measurement, which is feet, and because we're talking about the area, it is squared. All right, and we are doing number 4. The dimensions of an above ground rectangular pool are 20 feet long, 14 feet wide, and 4 feet deep. A, how much water is needed to fill the pool? So let's think about it. If we have a pool and we need to know how much water we're going to need, well, first of all, we're going to need to know the volume of that pool. So volume equals length times width times height. And this is another formula that you are going to have to memorize. So we're going to use all our dimensions from our scenario and put them into our variables. So my variable for length is going to be 20 feet times my variable for width is going to be 14 feet times my variable for height, which is 4 feet. So now with our calculator, we are going to put in 20 times 14 times 4. And that is going to get us 1,120. And then what about our unit of measurement? Well, this one's a little different. Because we're multiplying here, how many feet do we have? We have 1, 2, 3. So when we write this, I know my unit of measurement is feet, and because I have 3 feet here, it's actually going to be feet cubed, which we could also say to the third power. Now let's move on to B. If there are 5.24 gallons in 1 cubic foot, how many gallons are needed to fill the pool? So here we're going to use our 1,120 feet cubed, and we're going to multiply that by 5.24 gallons. Now, with your calculator, go ahead and type in this problem, 1,120 times 5.24. All right, and the answer you should have got is 5,868.8 gallons. Once you have all that done, let's move on to number 5. So number 5, Gary is learning about mosaics in art class. His teacher passes out small square tiles and encourages the students to cut up the tiles in various angles. Gary's first cut tile looks like this. A, write an equation relating the angle TIL with the angle LIE. So here we're going to have our angle for TIL, and then for our angle LIE. Now, when it says relating, that means we need to put them into an equation. The equation is going to be 4m plus m minus 15 equals, now what is the angle here that both of these angles equal to? Well, it is 90 degrees. So now for B, it says solve for m. M is the variable that we are using in this equation. So now I'm going to start with the equation that I just came up with. That was for A. So I have 4m plus m minus 15 equals 90 degrees. So now when I look here, I need to look at my parentheses. Okay, and in my parentheses, I see that we have an addition sign outside of it. That means that all of my values inside of my parentheses are going to stay the same. So when I rewrite this out, I have 4m plus m minus 15 equals 90 degrees. Now we do what is called combining like terms. Here I see that I have 4m, and the other term that is like 4m is plus m. Now the term that is by itself is minus 15. because 15 does not have a variable associated with it, so we know it's not the same term as these ones. Let's go ahead and combine these terms. I have 4m plus m. If I have 4 m's and I add one more, that gives me 5m minus the term that is by itself 15. So now I have 5m minus 15 equals 90 degrees. Now, I still need to get m by itself. When I look at the other term that m is not associated with, it is 15. And I need to get rid of the 15, and to do that, I'm going to add 15 to both sides. Remember, what I do to one side, I have to do to the other. So now I'm actually going to move my work up here. And so when I add 15 to my left side, I am just left with 5m, because negative 15 plus 15 gives me 0. And then I have 90 plus 15, which gives me 105. Now, looking at 5m equals 105, I need to get rid of my 5, or I need to factor my 5 out. How I'm going to do that is I am going to look at my equation here and say, what kind of equation is this? Is it addition, subtraction, multiplication, or division? Well, here I see it's multiplication. So to factor out my 5, I'm going to use the multiplicative inverse of 5. The multiplicative inverse of 5 is going to be 1/5. So I'm going to multiply both sides by 1/5. Okay. Any value times its multiplicative inverse is always going to give us 1. So now we're left with 1m, which can even equal m. And technically, you do not need to write the 1 in front of the m, but if it makes you feel comfortable, go ahead and do so. So now I have m equals 105 times 1/5. Now here we have a whole number times a fraction. And to get that whole number to be a fraction, we can put a 1 underneath of it. So now I need to multiply my numerators and my denominators. For my numerators, I have 105 and 1. So 105 times 1 is going to give me 105. So there is my numerator. And then for my denominator, I have 1 times 5, which is going to give me 5. Now, in fraction form, I have m equals 105 divided by 5. Go ahead with your calculator and type in 105 divided by 5. When you get that answer, that should give you an answer of 21. So now we know that m equals 21. Let's move on to C. For C, it says, what is the measure of angle TIL? And TIL is this angle right here. TIL is 4m degrees. So now that I know that m equals 21, I'm going to substitute 21 in for m. So now I have 4 times 21, and go ahead with your calculator and solve this. 4 times 21 is going to give us 84. So we know that the angle of TIL is 84 degrees. Now finally, what is the measurement of LIE? And that is m minus 15. So again, I'm going to substitute 21 in for m. So now I have 21 minus 15. And 21 minus 15 is going to give us 6. So now we know that that angle is 6 degrees. Now, a way you can go ahead and check is we know that both of these angles equal 90 degrees. And when we put our two values here for 84 and 6, we know that 84 plus 6 is going to give us 90 degrees. All right, well, that concludes the end of our video. Please make sure if you have any questions for your teachers that you contact them before you take your test. All right, see you in class.